How is it that in space, despite the sun's presence, the surroundings look black? Apollo photos show a black sky, even with strong sunlight on the surface. The answer to this question can be summed up in 2 words: no atmosphere. Planetary atmospheres cause bright light to scatter. Atoms, molecules, and dust interact with photons, causing them to diffuse through increasingly dense layers as they near a body's surface. On Earth, our atmosphere preferentially scatters blue light, so the daytime sky appears blue. And although Mars has an atmosphere that is some 100 times thinner than our planet's, there's still enough of it to cause the sky to appear a deep grayish blue, and if Martian dust is whipped up by the tenuous surface winds, the sky turns a salmon pink. On the Moon, there is no atmosphere, so there's nothing to scatter photons, even from a brilliant source like the Sun. In fact, if you could find a deep enough shadow that shields your eyes from direct sunlight as well as light reflected off the surrounding terrain, you'd be able to see the stars. There's another factor that plays into images taken by the Apollo astronauts from the Moon's surface, and that is the limited dynamic range of the film used to record their surface activities. The sunlight is so overwhelmingly bright that, in order to record highlights, the shadows and sky had to be heavily underexposed. Why is space black? Your question, which seems simple, is actually very difficult to answer. It is a question that many scientists pondered for many centuries, including Johannes Kepler, Edmund Halley, and German physician-astronomer Wilhelm Olbers. There are 2 things to think about here. Let's take the easy one first and ask, why is the daytime sky blue here on Earth? That is a question we can answer. The daytime sky is blue because light from the nearby sun hits molecules in the Earth's atmosphere and scatters off in all directions. The blue color of the sky is a result of this scattering process. At night, when that part of Earth is facing away from the sun, space looks black because there is no nearby bright source of light, like the sun, to be scattered. If you were on the Moon, which has no atmosphere, the sky would be black both night and day. You can see this in photographs taken during the Apollo moon landings. So, now on to the harder part. If the universe is full of stars, why doesn't the light from all of them add up to make the whole sky bright all the time? It turns out that if the universe was infinitely large and infinitely old, then we would expect the night sky to be bright from the light of all those stars. Every direction you looked in space you would be looking at a star. Yet we know from experience that space is black. This paradox is known as Olbers' paradox. It is a paradox because of the apparent contradiction between our expectation that the night sky be bright and our experience that it is black. Many different explanations have been put forward to resolve Olbers' paradox. The best solution at present is that the universe is not infinitely old, it is somewhere around 15 billion years old. That means we can only see objects as far away as the distance light can travel in 15 billion years. The light from stars farther away than that has not yet had time to reach us and so can't contribute to making the sky bright. Another reason that the sky may not be bright with the visible light of all the stars is because when a source of light is moving away from you, the wavelength of that light is made longer, which for light means more red. This means that the light from stars that are moving away from us will become shifted towards red, and may shift so far that it is no longer visible at all. Note, you hear the same effect when an ambulance passes you, and the pitch of the siren gets lower as the ambulance travels away from you. This effect is called the Doppler effect. Why is the sky blue on Earth, but black in space or on the Moon? October 2000. Almost everyone admires the lovely blue sky displayed on a crisp, cool autumn day. As early as 1500, Leonardo da Vinci tried to explain the sky's color. His notebooks show he monitored sunlight passing through wood smoke, suggesting he understood the basic phenomenon of light scattering. Although the complete physical explanation for the blue sky is complex because of length limitations, we will focus on the primary mechanism. In the 1870s, the English scientist, Lord Rayleigh, weighed in with part of the explanation. But to understand his rationale, we need to know 2 things about how we perceive light. First, all colors of visible sunlight from the shortwave violet to blue, green, yellow, orange, and the long-wave red, are emitted by the sun, yet not in equal amounts. The predominant color in the visible spectrum is blue. Second, our eyes detect green light better than the other colors and they perceive blue light pretty well. Mixed together, all the colors of visible light appear white to us. Imagine a cork at rest on the surface of a tranquil pond. A stone is then dropped into the pond, sending out waves that cause the cork move up and down. The cork receives wave energy and then oscillates up and down, and in a similar manner light waves can interact with air molecules. However, the air particles do not keep the energy from light waves that fall upon them, but quickly re-radiate that light energy in random directions. Hence the initial light that was coming from a specific direction is now scattered, re-radiated, in all directions. This scattering depends upon particle or molecule size and the wavelength of the incident light. Scattering is proportional to 1 divided by wavelength to the 4th power. The long waves of sunlight, red, are less effectively scattered than the shorter ones, blue, by the small air particles in our atmosphere. Since red light has a wavelength, 700 nanometers, about 1.7 times greater than blue light, 400 nanometers, Rayleigh's findings show that blue light has about 9 times greater chance of scattering than red light. This scattered blue light goes out in all directions through the atmosphere and comes to us from throughout the sky during the day.
Well guys, this video is over. I hope you enjoy, and if you enjoy, be sure to hit the like button. Until the next video, have a great time.